All right. Hi, everyone. Guess we're about ready to get started here. Thank you for coming. This session, we're going to talk about building in the cloud best practices. We've got a very diverse panel up here, 5 very different entrepreneurs from different types of verticals, anywhere from gaming to security to construction, platform as a service, and even some nice big data and some analytics. So my name is Joe Ziegler. I'm going to be your moderator. I'm an AWS technical evangelist. And my background, my first startup was a small one called Netscape, which means I'm actually quite old. My second startup was one that eventually became part of DoubleClick, and then Google. So those are my good ones that I talk about. I won't talk about barbecue.com or washyourpet.com or any of those. But thanks again for coming. Let me just go ahead and introduce our panelists. We'll probably start off here at the end with Ralph. So we have Ralph Goody with PlanGrid. You just want to give a little... Can you guys hear okay? Yeah, we're all right?
Hi, my name is Ralph. I'm co-founder and CTO of PlanGrid. In a nutshell, we're blueprints on the iPad. We're a lot more than that now. We also have an iPhone app. We basically allow collaboration on construction sites. We mostly deal with architects, general contractors, stuff like that. And we leverage AWS for a lot of back-end processing, a lot of cool OCR type stuff, very awesome things.
And next we have Adam Damico from Okta.
Hi. Okta is the central connector and broker for our company, our customers' identity and access management. So we tie together all of the SaaS apps that they use with all of the apps they have on-premise, together with their Active Directory behind their firewall or their LDAP directory, any HRIS type systems or other identity providers they have out in the cloud or on-prem. So really, enterprise identity as a service.
And next we have Bill Platt, who's the Senior Vice President of Operations for EngineYard.
Hi, yeah, I'm Bill Platt, run operations for EngineYard. EngineYard's a platform as a service. EngineYard is used by thousands of customers, developers to make, deploy, and then run applications that we see help change the world.
Fantastic. And then we have, for next, we've got Sarah Novotny. She is the CIO of Meteor Entertainment.
I get to talk about Meteor Entertainment now. We're a brand new video game publishing company, and I think my marketing team would kill me if I didn't mention that our first game, Hawken, is being released on December 12th.
So shameless plug.
Shameless plug. 14 days from today. Why I'm here, I'm here doing a favor to people, talking on a panel. But in 14 days, we have a first-person shooter mech game called Hawken coming out, and it is published entirely on the cloud.
And next we've got Kate Matsudaira. She's the VP of Engineering for Decide.com.
And if you're not familiar with Decide, what we do is we're like a next generation consumer report. So we take terabytes of product data and pricing data and reviews to kind of distill everything down to a simple score or recommendation to help consumers decide what to buy and when to buy it.
Great. So the format we'll do is we'll have a few questions that I'm going to go ahead and throw out to the panel. And then I've left some time at the end if you have any kind of Q&A. We've actually got a microphone set up back there. So if you do have some questions, feel free to go ahead and line up. If we don't like the questions, I have bouncers actually borrowed from the casino who will just kind of pull you aside and have a little talk to you. So, well, let's get started. As a starting point, just kind of interested, what are some of the different services on top of AWS that you're actually using? And you guys can just jump in.
We use S3, SQS, EC2, also a little bit of CloudFront, and maybe Glacier we're just kind of putting our toes into.
For us, it's EC2, S3, a little bit of Route 53, IAM, and Glacier. We're also dipping our toes in that one.
Yeah, for EngineYard, we have heavy EC2 and S3, now also EBS with Revision IOPS, which is really great stuff. And also we use CloudWatch and the Autoscaler for our Elastic PHP offering. And we've also done ELBs for our customers as well.
I may have the most robust list here because we actually use 13 services and are testing another one. So I came with a cheat sheet. We use EC2, DynamoDB, S3, SES, EIP, ELB, Route 53, CloudFront, CloudWatch, SNS, SQS, EMR, RDS, and we're testing Redshift.
So Sarah now wins the award for the most three-letter acronyms spoken in any one answer. Yeah, it's all done.
So we use S3, EC2. We do a lot with EMR, RDS. We use CloudFront, like a lot of everything, SNS, SQS.
So you're
Dynamo.
Actually, so for Decide.com though, you're doing big data. You're actually processing this big data.
Yeah, no, we do a lot of, the majority of our company work is in our algorithms, our recommendations, and being able to do predictions. So one of the things that we do in the cloud is we'll test 5 different algorithms simultaneously. So we'll spin up, 1,000 different EMR routines and actually benchmark them against each other. So it allows us to iterate very, very quickly. I have a whole team of data scientists doing nothing but that, basically.
So basically, you can control how fast you want the outcome from these questions because you can spin up more instances.
Exactly.
Fantastic. Fantastic. Now, Ralph, we talked a little bit before how you're using S3. And you're actually talking with you've got a mobile app.
Sure, I'd love to talk about that. So one of the biggest advantages we found with S3, one of the quickest wins we've had, is one part of our application allows people on the job site to take photos and pin them to the blueprints on separate spots. We enabled this feature, it was very popular. You could take photos, put them on the blueprint. But it wasn't as useful having it just on the iPads and the devices. So I think this only took me about an hour or two, but basically one night I thought, everything should just upload automatically, like Instagram or something like that. So whenever someone takes a photo on the job site now, it automatically uploads, it directly goes into S3. So it just shoots right in there without any type of blocking issues. We don't have to have an API for it or anything like that. And we obviously have a write-only key for that. And then on the website, you can just quickly access all the photos that were taken on the project. And this is extremely powerful for litigation, other purposes. People might not even think about the pictures they're taking, but if we catalog everything, date it, store it in an S3 bucket, it works out really well.
I've got lots of customers that I've worked with, and they've built fleets of web servers to pull in information to pass it to S3. Yep. And I think you could easily say that one of the best practices is if you're in that scenario where you can take and push directly to S3,
yep,
bypass all that. You're going to save yourself so much money, because compute's going to be mostly your highest cost.
Yep, absolutely. And you have to deal with all the blocking stuff. We would have had to punch a bunch of API workers up, to deal with it while it was blocking, while it was uploading. And they're big photos. I mean, the iPad 3 now takes 5 megapixel photos. I mean, it takes a while to upload those.
Fantastic. So we're talking about some of the best practices. Adam, I know that you've scaled out your architecture, particularly across availability zones. Can you talk to that a little bit?
Yeah, so we take great pains to make sure that we have the best possible redundancy. So we're an old enough customer that we still have 5 availability zones in US East 1. So that gives us kind of a leg up when there are hiccups in various zones. And I can honestly say that if there was a 6th zone available tomorrow, we would probably spin up machines the next day just to cover all the bases. And compute is definitely our biggest expense, but that's mostly because we are fairly well over-provisioned just for the point of fault tolerance. So, and I think AWS makes it so easy to replicate into multiple zones. We're talking about 1 to 2 millisecond latency between data centers. That's a huge benefit, and it's something that you should definitely take advantage of, definitely as a best practice.
So for some of our other panelists, what are some of the steps that you've taken for high availability?
At Engine Yard, one of the things we've been doing and continue to do is design with that in mind, and in particular, we take advantage of all the regions as well. So we place our customers' applications, our customers make applications, so those things get placed across the regions as they would like them to do, in addition to the availability zones. And we think that's also a really good best practice if you can specifically design with that in mind. Know that you're going to want to do that, so when you build what you're building, you know you're going to use multiple regions, multiple availability zones, and if possible, make it the default, because that's by far the best answer from the customer.
And then Sarah, you're doing some
Oh, we're doing all sorts of fun stuff. So our use case is slightly different in that most of our compute power comes in the form of game servers. So any one game server will only have maybe 30 different users on it at a given time. But our biggest pain point is latency. So by making use of the cloud, I was able to put game servers within 50 milliseconds of every customer. So I actually did a quick list here. I have game servers in US East 1, both of the US West locations, the EU West, Singapore, Japan, and Australia already. And we're looking to, actually we're pushing hard on zones where I want more compute power, because Eastern Europe is someplace I really need compute. And as far as availability, our biggest pain point for availability is actually at the moment DynamoDB, not because it isn't highly available, not because it isn't great, but because it's served out of a single region and you don't have replication to multiple regions at this point.
Okay, well, let's build on that. Let's talk about building a global architecture. I mean, with AWS, we actually have 8 regions that are available to our general customers. We just launched in Australia. Yes, that's where I'm from.
Australia.
Anyone using Australia in the audience? Okay, you're all going to get stickers from me later on, because we talk about building global architectures. Obviously, there's some restrictions in that. How do you share data across those regions? As a rule within AWS, we never move data between regions. That's all routed on the public internet. How do you, as you're scaling your applications up and having this globally available architecture, how do you deal with that? What are some of those best techniques?
So one thing, a design principle that we took from the very beginning is, in order to make it okay for your application to move data around between regions when it's over the public internet, when there's not syncing, when it's long distances, you have to design the application with graceful modes of degradation. And that's planned and unplanned. If you've got a loose connection of services, you have to make contracts between those services to make sure that some of them can go read-only at some time, some of them then go read-write, but they can degrade either on purpose or accidentally if something goes bad, such that you can tweak data and move it around when you need to. So the graceful modes of degradation is a key piece of that.
So far, I've punted that problem. No, actually, one of the things that we're looking at, because at the moment Dynamo is a risk for us being single region, is we're racing whether or not I can vet Riak and our own cluster system, as opposed to whether or not Amazon can bring us multi-region replication. Who's going to win is the big question today.
On our side, too, we're waiting for more facilities for cross-region data migration to become available within the API. And that's all kinds of things like AMIs, AKIs, ARIs, and ways to more efficiently tie together VPCs in multiple regions is another thing that we're waiting on. We're doing questions after.
Yeah, we'll do questions. We'll do questions just at the end. Okay.
Oh, I was just going to say, so we're not as much as like a global thing, but we do care a lot about failing and handling failover, and we designed our systems to be built that way. And I think one of the smarter things that we did was we've really separated the notion of dynamic data, think like your user data and things that people are interacting with all the time, and reference data, which is if you go to our site, because we're an e-commerce shopping site for the most part, it's all reference data that is static, and it's not static, it changes every 10 minutes, but for the most part it's a fixed set that people aren't writing to. It's very heavy reads. And so for us, just taking advantage of that, and we store almost all of our data in a very interesting way compressed. So we compress terabytes of data into gigabytes and keep it all in memory. And so it allows us to both have really fast, but also that's part of how we spin up instances. So we can spin them up anywhere, and they have 90% of what our website functionality has. So that's really powerful.
That segues into a really good point. How do you scale up for traffic? What are some of the techniques that you've used to actually be able to handle, especially like for gaming, you have a very, very spiky workflow. For Decide.com, obviously you're dealing with massive amounts of data. How do you scale up in order to meet your customers' needs?
Did I mention we're launching on December 12th? What we're doing to scale up is we're actually taking sort of a page out of the Apache workbook here and saying we need to keep a minimum number of spare servers in any one region. And when we start to see that that minimum number of spare servers drops, or that we start to have capacity that is underutilized or overutilized, then we make changes in what is running out in that particular region. So we're doing that right now with custom scripts and with Chef, and it is not as automated today as I'd like it to be. That's something that is coming in first quarter because it's going to be a pain point for us very quickly.
I was just going to add there, we have an interesting perspective at Engine Yard because our customers are actually the people who do a lot of that, right? So our job is to give them facilities like different types of databases, different types of ways to do it. But we see people doing interesting combinations of having ready additional capacity, like you were describing, Sarah, having ready additional capacity, but also taking advantage of, and we do this too, taking advantage of reserved instances as a mechanism to make it easy to do that, right? So you know you're going to have the capacity, but you know you're not going to use it all the time, so you can keep your costs down a little bit by doing that. So you do that. Also keep some ready capacity ready to go when you need it, but not all of your capacity. Spreading across regions actually helps that too, right? You know, as Sarah was saying, making sure that I can feed the regions, feed the users from where they need to be. And then also having a capacity plan and knowing what your you got to measure it. That's probably the hardest thing people don't realize. And like CloudWatch to feed autoscaler is interesting, but it's not enough. So you need to measure a lot of things. We literally monitor and measure ourselves from 3 different tools, from 3 different infrastructures back into Amazon, just to make sure we have the right data. So those kind of things you have to think about when you're thinking about all that capacity planning.
From a data perspective especially, I mean, you have so much data that you're dealing with at Decide.
Yeah, I mean, we use hosted Chef, or if there's people in ops code here. And that works really well because it allows us to spin things up really quickly. But we also tend to operate with excess capacity at any given time and really monitor everything. Just to echo what Bill said, I think just having a lot of data and really knowing what you're doing and how your services are running.
How about from a design perspective, to be able to actually scale up and just, you know, one of the things with AWS we talk about is the elasticity of the cloud and being able to scale out horizontally. How has that affected the design of your applications? Like we talked a little bit about where do you keep state?
Yeah, well, I think that's a big part of it, right? Like really thinking about stateless as much as you can for as much of your systems and building that into the UI where you can deploy parts of your system and that will only show up and things like that, and just thinking it through and how you design your software and access your data.
We've had a lot of success with a simple queue-based system using SQS. So basically, a lot of the operations on our website are very long-running tasks with image processing. And as long as we design everything to run as workers, where one worker takes one job, and all the jobs are pushed back into a database or something, it kind of gives us a nice stateless feel to it. So if we need to like spin up 10 servers out of nowhere and like put a bunch of workers on them, that's a very easy thing to do. I mean, we can run workers wherever we want them using SQS and stuff. So it works out nicely to not have to worry about, like, we have no state on our instances at all. Like, I mean, there's just the code running workers, and that's all there is.
So you basically have a loosely coupled architecture.
It's completely loosely coupled, exactly. And that's just it's been great, because whenever we have to worry about scale, which we don't have to worry about quite as much as some of the other guys here, the thing when we do have to worry about scale, it comes quickly. You know, suddenly 3 hospital projects join our system, and they just kind of blow it out of the water all of a sudden, especially since we're a pretty early stage startup. This happens more often than you'd expect. And to be able to just kind of bring workers up and not worry about any other architecture than like one variable, which is like the number of workers you have running and working on those tasks, it works out really well. And we've taken that architecture and applied it to lots of other things besides for just image processing. Also, any type of asynchronous task on the website kind of works with the same type of architecture.
We've gone ahead. We've gone ahead and worked in very service-oriented, loosely coupled architectures. So our game servers are completely independent. They don't keep state. They're completely ephemeral. Our game services don't keep state. They're completely ephemeral. They define what services they offer based on the capacity of their peer nodes, and then they feed everything into queues, basically, in order to handle things that way. Or flat files. Yep, flat files is where we put most of our data for analytics, for the initial path. If it's not state that the user is going to be checking immediately, it's going into a flat file to be processed hourly.
Yeah, I was just going to say another thing about user data is you can keep a lot of it sometimes on the client, depending on what it is, either cookies on the client side too, if it is that type of data. But flat files are the key to scaling. We do everything with flat files, and then we'll take snapshots and just load it that way.
So I'm interested to hear a little bit from Adam, because you do have actually, at one point or another, you have to deal with some state. And with what you're offering is, I mean, basically you're offering authentication and validation and SOS. How do you deal with state and being able to scale up the architecture?
Well, we've got everything right now just at the bottom data layer. So everything above that is stateless, just like the others here were talking about. And we have an advantage over a lot of other businesses in that we're not a content-centric operation. So it's not we're not moving a whole lot of data around. We're a little bit latency sensitive, but we're not. Our bandwidth needs are pretty meager. So we have the luxury of having relatively small databases in comparison to what other companies that are leveraging cloud are probably using. Now that being said, where we're really going to start doing some innovative things is when it comes to how we structure those data sets, where we go polystructured and where we go relational, where we're going to use flat files, and how, in relation to what I said before about the graceful modes of degradation, how do we get all of those disparate data sources with all the different schemas operating in that kind of paradigm for nicely quiescing services before various operations and dealing with something that catches fire.
I'm interested too, who's implementing NoSQL as kind of a fundamental part of your architecture, whether it's Dynamo or Couch or anyone else?
All of our client state, all of our end user state is stored in Dynamo at this point, as well as the entire item store or catalog. Eventually the wallet will be in that. At this juncture, I have an interesting counterpoint to your clients can have the user state.
Well,
it depends on your use case.
Well, it also depends on how long your data can be inconsistent, right? If you can build your services to handle inconsistency, which is what, like for us, it's mostly login or like alerts. And so if it's not up to date, it's less important. So I think it depends on what. Yeah.
Absolutely, and in our world, it isn't even the inconsistency, because we build for inconsistency, because even if you write your data into a queue or into Dynamo, you don't know that what you're going to read out is what you wrote, half a second ago. But for us, the reason that we can't keep any of the user data on the client is for game hacking reasons. So all of our user data has to be stored server side, or somebody's going to hack their number of credits, or somebody's going to hack their user or the mech profile or whatever. So it can't be there for security's sake.
I was going to add that we see a cross-section of types of applications, right? And so there's a lot of gaming and gamification and game platforms and API sets on us, and they're all NoSQL right now. They're all doing that. Also, a lot of media is going there fast now too, because it's just a little better way for them to keep track of all the different types of documents that they're having. So we're seeing that into a bit of a trend in the last year and a half, 2 years. It's just quickly taken over those two areas in our customer set.
Sarah, you're saying a bit that there's some downsides to the
There are some
NoSQL
downsides
world.
to NoSQL. There's a variety of them. One, you may be finding data scientists in Seattle, but I'm not right now. I'm having a horrible time hiring for people that can handle.
Do you want to do your shameless
I do.
hiring
Shameless
plug?
I'm hiring.
There you go.
I need data scientists. I need people who are excited about non-relational databases and who can help me pipeline it out to analysts who want it in a SQL database, consumable in their standard formats. So another shameless plug, pardon me. But there's downsides in that sense. And for me, one of the downsides in Dynamo is it's the only service that I use that I have to provision for my full throughput. So it isn't elastic. I'm not taking advantage of the pay-as-I-go on demand. I have to say that at my peak utilization, I use this many IOPS per second, and I'm paying for that. And that means that right now, Dynamo is 75% of my bill, which is horrifying.
To be fair, though, you can actually change the provision on Dynamo.
You can change the
but it's not as
provisioning.
fast as it would be, in terms of
It
auto-scaling.
isn't. You can change the provisioning, and I think now you can change the provisioning 2 or 4 times a day.
They might have increased that. You can always spend more.
You can
with
always
us.
turn it up.
You can always turn it up.
You can turn it down
But
4 times a day.
turning it down is more limited.
You can turn it down
That's
4 times
true.
a day. So you can do it sort of as step costs, but they're daily step costs instead of the incremental. So for me, and to be fair to Amazon, my 75% bill is, we have a lot of tune-up to do there of the way we're doing it, but that's something that is for me, the pricing model is more complicated there. And there's great reasons for it. They need to be able to provision for that capacity and have guaranteed throughput. But in my world, because I don't care if the data is inconsistent, it's not what I need.
We also use a NoSQL database. We use Mongo, and we've been really, really happy with it. And I've worked with a lot of SQL databases for Oracle and everything else. And for me, it's more of I can wrap my head around objects a lot quicker than I can wrap my head around SQL statements. And when we don't really have to do we do a lot of data analysis on our data, and it doesn't require putting it into SQL, because you can just write filtering and reductions in Mongo directly and kind of get the type of statistical data you'd be interested in. I mean, the hard part with Mongo is if you have different collections, they don't cross-reference each other, right? So that takes a little bit of time.
I would say, similarly, the customers we're seeing doing these things, all the different NoSQL databases, you can expect sort of 2 stages. Get the benefit, like Sarah was talking about originally, and then maybe you're going to have to go back and tune and figure it out a little bit more to get it right for your running, for the running world, for the real world that you're going to run it in. So expect that if you go down that path. But it does solve problems, and it does give the benefits that Ralph was talking about.
So part of the takeaway there is, if you're living on the West Coast and you're looking for a job, start studying NoSQL. I'm available to tutor you. I'll do it on an agent basis. I just want 10% of your first year's salary. It's a very fair deal. Look me up after the session.
And you might want to do it before December 12th. Right.
Yeah. Let's talk a little bit about agility and the agility, especially when you talk about kind of web infrastructure. But I'd like to talk about, who's doing dev and test on us? All of you are doing dev and test on us. So are you doing agile development? Are you doing Scrum, or what different types of development methodologies are you using?
We've taken most of the aspects of Agile that we find to be useful. I think I can honestly say that we wouldn't be where we are without AWS, which is a great plug for you. But mostly it's because there's huge value. And as an ops guy, I find incredible value in having our test and dev and staging and production environments all on the same building blocks. That's huge. And when I can, not only that, but when I can hand out instances that are the same as my production instances to developers, just at whim, that's also extremely, extremely valuable. So, gone are the days when we have to worry about why something works on the developer workstation but not in production, and we have these surprise bugs. That just doesn't happen anymore. So that's a big win for us.
I can say, as a developer myself, I have broken production and not been able to reproduce it well in my development environment. But in this type of scenario, I can just copy that production environment, sandbox it, and work on it's essentially the exact same environment.
We kind of live by a few commandments, and number one is live in the cloud. And by that, we literally used to own servers. We got rid of them all. And we got rid of them, and then the developers actually started to solve the problems you have to solve in order to actually be good in the cloud. And I think it's a really important best practice, is to literally develop, test, stage, do it all exactly where you're going to end up running production anyway. You can sandbox, it's all easy to do, but take advantage of the fact that it's there. The one caveat, you make it real easy for developers to use capacity, and they will use capacity. So make sure you run your reports at the end of the month and know how much you're spending as well.
Darn, don't spend more money on us.
I think it's the holy grail of operations to be able to run dev and test on identical instances or used to be hardware and know that what you've used and what you've tested will actually play out. The same is the case for perf testing, and nobody's said that yet, but when we want to performance test, we can build, even if it's for an afternoon, the same number of instances that we have running in production, and that is huge. It was a CapEx that was never permitted when you had to buy hardware. No one would ever, I mean, they might give you 1/3 of a stack, or they might give you, one web server, one application server, and one services box. But you were never able to say, so if I had 50 of them out there, what would that look like? But you can do that for an hour, and you can do that for 5 hours and then turn them off. You do need to make sure that your developers remember to turn off all that extra capacity, though, because I have to say some of them don't.
But like as a developer, I can say, I mean, how powerful is it to know that that check-in that I just made into the main line, I can test that and I can know pretty much empirically I'm going to degrade performance by 5% because I can spin up the exact same environment. I can use. Does anyone use bees with machine guns? Have you guys heard of that? Bees with machine guns. It's a load testing app. It's done by the Chicago Tribune. It's basically a distributed denial of service attack. Do not use this on other customers. But it allows you to actually you can have the exact type of traffic from around the world hitting that code base. So as a developer, you're immediately going to know, well, some change I've done has degraded performance or increased it. In my case, it's usually degrades it.
I would add to that, your point of making sure you're testing like that. We do continuous integration and continuous delivery, which means it's really important to have that space where you're checking the stuff, and we release a lot.
So let's talk a little bit about that. Tell us about who else is doing continuous delivery? Hey, Bill's the man. How often do you actually bring up new production code?
We'll do it every day, as needed, right? So we get a bug, we get a fix, we'll put it out there today if we have to. We can do it all the time. We like to bundle up stuff when it's bigger features, right? We like to kind of bundle it up and have it released together. But we often do what we call limited availability followed by early access followed by, right? So you give it out and you can put it behind a flag and you can only give access to certain people. All that's so easy to do with Amazon underneath because you can just check it yourself. Give it to yourself as your first customer, right? We are our own customer in the sense we are an application running on our own platform. So we have to do that all the time. And literally we've had multiple releases in a day. Unfortunately, usually because we have to, we didn't want to, but we did. But it's really important to be able to do that. So you really have to line up that whole test infrastructure ahead of time and then know how you're going to do it.
And you fully have infrastructure as code throughout your environment?
Yeah, I mean, we treat it as if it's just another hunk of the code, right? For us, it's actually really important as a platform. You're kind of trying to make that abstraction. You're trying to make it easy for the infrastructure to just be a call, essentially.
We talk about that a little bit, infrastructure as code. Everything within AWS is an API. There's nothing that you can't do through an API. That means their entire production environments can be represented by code, and it's usually a combination of maybe Chef, Puppet. We've got CloudFormation on our end that plugs into that. Who's fully utilizing infrastructure as code?
Yeah.
So I was going to add so commandment number 1 was live in the cloud. Commandment number 2 is the API is the truth. You have to think that way. When you do, you realize the infrastructure should be code to your application, right?
And one advantage of really thinking about everything as an API, because we do that as well, it means you can support lots of clients. So for us, that was really important. Mobile is a huge, huge component of our traffic being in e-commerce. And so being able to have, response, like a responsive website and an iOS app and all these things, but by building all of our backend services as APIs, it makes it very, very easy.
So do you treat that portion of your architecture just as you would with the rest of the application development? Is it going through source control? Is it getting version?
It's
Does
version.
it go through your continuous integration server?
Exactly. It's exactly the same as everything else. You don't update anything without updating the chef recipes and all that.
So, oh, go ahead.
I was going to say that we've actually been kind of struggling with that a little bit because we're, unlike I think a lot of customers of AWS, our organization is, we do have classic operations and core software with a little bit of separation in between. And we've got some DevOps going on, but what we're struggling with now is all of these, we've got system administrators who are now, of course, software engineers. Well, how do you do continuous integration and testing of infrastructure if it's not core code? There's really, the structures are a little bit different, and the way you lay it out is a little bit different. And so we've got things going on, like every time somebody uploads a cookbook, a bunch of servers get launched, and we try and build a whole stack. And does that work? Are there errors? Do we get a bunch of gacs in email and that sort of thing? But we're still kind of ironing that out. I think there's some interesting places we can go. But if anyone has ideas about that, I'd like to talk after the talk here.
So just logistically, I think we'll talk for about 5 more minutes, and then we'll take questions. If you do have questions, you just can line up behind. There's the podium back there with the microphone.
Can I make a comment about APIs? It seems like a really obvious statement, but I've found more than a few devs that don't necessarily think this way. When you're working with APIs, you get error codes back. Check them. Know what it means.
Write that one down. Check
Yeah.
error code.
A 200 is different from a 203, is different from a 201, and they give you information. It really is sort of a low-hanging fruit thing, but I've found a lot of people go, hey, that was a 200, that was a 200 series, so it was successful. Well, not necessarily. So that's kind of a low-hanging fruit one.
She's got a good point, and if you haven't done this, think about living in the error stream, okay? Because it's there all the time, and you really have to pay attention to it. And because of the ease with which you can bring up environments, and you can spin them, and you can kill them, and you can tend to ignore the errors, but you don't want to. We have customers that are themselves API services. That's what they do. And some of them are specifically error management and error handling and logging handling services. Invest in them. Make them your friend. They're helpful.
I like Bill. He lives in the cloud sometimes. Sometimes he lives in the error streams. He's everywhere.
My preference not to live there, but
how about a time, talking about agility, tell me an experience that you've had in which you've been able to, iterate quickly, maybe fail fast and fail forward because of this type of infrastructure.
I'll take that one, at least the start of it. So when we were first starting our startup, we had maybe 20 users. We have very high, intense using users. They upload a lot of data to our stuff, and there's a lot of processing that's required for that data. Like, we can easily put a lot of data through our system. And being able to go from like 20 users to 200 users was a big deal for us, because we only have like one part-time DevOps person, and that's me, and I also do all the iOS development. So without being able to just spin up new instances and get things going very quickly, it would have been very challenging. And then kind of as a startup growing into like, I don't know, a teenager startup is like kind of putting in deployment code, continuous integration, maybe a test here or there was kind of fun to write. So we were kind of able to build all that up on AWS without having to mess around with other architectures and just kind of keep the pipeline going, which is very nice.
We've gone from 8 people to 80 people in less than a year. We've gone from 0 infrastructure to production on 12.12.
and still hiring.
And we're still hiring, right. So for us, I'd say the only reason this is possible is the cloud, because if we had to spend a bunch of time and a bunch of resources trying to source hardware and rack hardware and put it into data centers and handle all that vendor management, we would not have been able to do this in the timeline that we have. I mean, there are lots of smaller, day-to-day answers to that, but for me, the big arc of this is that we just needed to have someone handling infrastructure as a service for us.
I was going to share an example of a fail fast forward situation. So Amazon's a great partner. We love them. However, there are times when Amazon can't tell everybody what's going to happen before it happens. And so sometimes, for instance, like the billing information might change. And we gather a lot of billing information to work with our customers. So when that happens, you sometimes don't know it, which is okay, because you can have a staging environment in which you can run the entire billing process overnight, the day that something changes, and you can know the next day what you have to change. And as long as you do that, in our case, you do that on a daily basis because we're billing on a monthly basis, you're ahead of the game. So if you can manage ahead of the need, And that's what's beautiful about what happens with Amazon. You can run that stuff independent of your actual production environment, know what's going to happen, make the change in time.
I'll give one quick fail-fast in a totally different arena, which is in around algorithm and data processing. So when we wanted to add new categories, like we had the models and things like that, and we were able to spin up tons of boxes and process millions and millions of products and terabytes of data very, very quickly. And that allows us to get to market much faster, launch things quicker, and that's really powerful for any startup.
Well, we've got about 10 minutes left. I'm happy to open it up to questions. I don't see anyone actually standing at the podium, so if there are any questions, I'm happy to go on more with the panelists. Does anyone have any questions for our panelists? They're just too awesome. Run up to the mic, please, please. And way to run. Well done.
I was wondering about best practices for stateless login handling.
Stateless, sorry?
Stateless login and authentication.
Okay, so the question is, how do you handle stateless login and authentication? Does anyone have any good best practices for that? Can you clarify that a bit?
So once you've got a user logged in, you're dealing with this stateless environment. You've got server A, server B, don't know anything about each other. What's your sort of best practice recommendation about how you handle letting server A that did the authentication
Okay, so the question is you've got an authenticated user and you want to be able to handle that user in a stateless way where that session is following the user between a machine in a horizontal type fashion?
I can probably take this. We do this because you have to do it in mobile, but we pass an access token that's stored on the client with every call. And then whenever it calls the server, it'll say like the person's logged in, not logged in, or whatever based on this kind of encrypted hash. And so that works really well for us.
Yeah, and we do the same thing, and there's ways to do that with HTTP using headers and stuff like that, authorization in the headers. There's very standard ways to do that work very, very well.
All right, thanks. Next question.
This is for Ralph, I guess. Earlier at the beginning, you mentioned that you're going directly from the client to S3. Security-wise, what are the best practices for that to prevent one tenant from smashing another tenant's files and whatnot?
For conflicting files.
Well, conflicting files, but I'm assuming you're also multi-tenant, and customer A doesn't need to be able to touch customer B's
Sure.
files.
Let me just repeat the question real quick. So the question is, what are some of the best practices if you're going to stream information directly from the client to S3?
That's correct.
Okay. One thing is to learn what universal identifiers are and use them everywhere. So basically, our whole architecture uses universal identifiers for everything. So that takes care of any type of collisions you might have with the keys in S3. The other things to keep in mind are S3 has like a tokenized access that has like a temporary access to it that you can use. The other thing is that it's not the most fun thing to do, but you can create using the Amazon identity configuration. What's that thing called? Using IAM, you can create specific users that have specific access to an S3 bucket, and you can enable things like it just allows the user to write to that bucket. That's key. Like, don't ever ship code with like any special keys in your code. Like, it's pretty easy to be like #define special access key and then compile. I mean, because that's still accessible in the application. All applications are accessible in iOS in some way. So I think the two best practices are my two, but you guys probably have others too. Anyone else?
We do a lot with feeds. Like, we get a lot of affiliate feeds, product feeds. So we really think a lot about our directory structures and the way we set it up. So if it's a full feed, for example, like a daily update, so 24 hours of product data, it would go in like a day directory. But then we also will do real-time pricing, where products will change prices every 10 minutes, and those will go in a snapshot feed. So we really are particular about how we set those up and format and have a method, so it makes it very organized.
Does that answer the question?
Yeah, also my other question was, how are you going from S3, or going from the client to S3 without hard coding some sort of credentials in the client?
Oh, sure. You make special credentials, special low-level credentials that can only upload stuff to a bucket. Yeah, so I mean, like, just those credentials. I mean,
you can create a token through the IAM API specifically for that.
Okay, that makes perfect sense. Thank you.
Thank you. Thanks for the good question. Yes, sir.
My question is regarding a point that was brought up earlier with separating dynamic and reference data, compressing. Oh, I'm sorry.
Yeah.
My question was regarding a point brought up earlier on separating dynamic and reference data, compressing the reference data and keeping it in memory. Is that synchronized across your instances, or is that terminated like on a schedule?
What we do is actually really interesting. I actually gave a whole 40-minute talk on this topic, so I'm happy to talk with you offline. But on each of our instances, the same thing when you access our website on that same instance is in the cache a full set of the product data that you can access. And then as you scale, we can add more, but those require a network hop, so it can slow things down. So we try to put as much of the head products and important products on that same EC2 instance. So that's why all our data is fast. If you go and run, kind of standard performance analysis tools on our website, you'll see we could do a lot more on the client, but we load full price graphs of years of history in milliseconds, or potentially seconds if you look across the network. But and so it allows us to really have top performance of our data in our app. This is also very helpful for data mining and algorithms because you don't have to read or write from disk.
Yes.
Hi. My question is something that Sarah brought up about
Can you come just a little bit louder? Sorry.
Yeah, it's a question for Sarah, something she brought up, talking about DynamoDB and how the user information goes through a queue first and then ends up in DynamoDB. How do you, what do you recommend for preventing timing attacks versus the synchronous queue? So it's something that, I would think would happen a lot in games where duping and all this sort of stuff happens.
Do you want to try and repeat that?
No.
No, okay. So most of our user data doesn't actually go through the queues. Some of it does, and that is state updates. But for example, a purchase wouldn't go through a queue, but something that, I shot someone would go through a queue. And XP would go through a queue, but not, an authentication. So the ideas that we've got in front of that are such that we build the application so that we know that the data we've just sent might not be there yet. And that's okay. So we've built it to not necessarily expect the same data, and where we need that consistency, we actually push it directly into Dynamo. Now, we still have potential latency problems on that, especially as we move, we hope, to a multi-location DynamoDB, but that's a problem to be scaled next, I think.
So we're just about out of time. Any last thoughts from any one of our panelists before we wrap everything up?
Well, since Sarah did it, yeah, we're hiring too at Okta. Software engineers.
There you
go.
Who is not hiring?
Who's not hiring?
Oh. You have to work for free down at that end. Well, I want to thank our panelists. Thank you very much, guys. Sarah, Ralph, Bill, Kate, and Adam, thank you so much for coming out and sharing your experience with us. Thank you, audience, for coming by. For those of you who are using the Australian region, I have stickers for you if you want to come up afterwards. But other than that, we appreciate your time. Thank you.